Hi students, welcome to Sunil's tutorial. I'm Sunil Medwani and today we'll be doing this chapter called as radiation. Right? Now let's see a couple of definitions to start with the chapter. What do we understand by conduction? Write this down guys. Conduction. Conduction is defined. Conduction is defined as a process of transfer of heat through material medium it is a process of transfer of heat through material medium without the actual migration of the particles of the medium without the actual migration of the particles of the medium from a point at higher temperature to a point at lower temperature. From a point at higher temperature to a point at lower temperature. Let's assume that guys I heat one end of the rod. Then what will happen? The other end of the rod will also get heated. Why? Because there will be transfer of heat from one end to another end, right? But are the particles actually going to move the heat? Particles going to move? No, right? You don't have actual migration of the particles from one end to another end. It is just that heat energy is transferred. How is heat energy transferred? In the case of solids, the particles are in constant random motion. Now when I apply heat to one of the particle, it starts vibrating with a larger amplitude. Its kinetic energy increases and it starts vibrating with a larger amplitude. It goes and hits the adjoining particle with that higher kinetic energy and transfers the kinetic energy into the adjoining particle, which then starts vibrating with a larger amplitude, and in this manner heat energy is transferred from one particle to another. So the particle only remains there, it's only that the kinetic energy gets transferred, and that's how the other end of the rod gets that kinetic energy and gets heated. So this method of transfer of heat is called as conduction. Next, convection. What do you understand by convection? Right, let's see this. What do we understand by convection? Now, convection is defined as a method of transfer of heat energy. Convection, it is defined as a process of transfer of heat through a material medium in which the particles of the medium carry thermal energy from particles of the medium carry thermal energy from higher temperature to lower temperature. Carry thermal energy from higher to lower temperature. Right? Let us assume that I heat a vessel. When I heat a vessel, then the liquid that is in close proximity with the heat will get heated first, and as a result of which it will start moving up. The liquid which is up, which is not that hot as compared to the liquid down, will move down, and that way the particles of the medium are going to move from a higher temperature to lower temperature to actually transfer the heat energy. This method of transfer of heat energy is called as convection. Fine, we get this in here. Next, third, what do we understand by radiation? Radiation is defined as a process of transfer of heat energy. It is defined as a process of transfer of heat energy in the form of electromagnetic waves for which material medium is not necessary. That is what is radiation. Now, every body which is hot, suppose if I have a hot body here, it is going to give out some heat energy. It is going to give out some heat energy in the form of electromagnetic waves, and that method of transfer of heat energy, as a result of which the surrounding is going to get heated, whether it is air or whatever is placed in the surrounding is going to get heated, and that method of transfer of heat energy is called as radiation. Fine, do we get this in here? Now, let's see this. So, we understand the three basic definitions of radiation. Now, if I have, what do you understand by radiant heat energy? Next, write this down. Radiant heat energy. What do we understand by radiant heat energy? Now I just explained to you what is radiation. In the case of radiation, a hot body gives out electromagnetic waves. Now listen to this, guys. The hot body gives out electromagnetic waves. These rapidly oscillating molecules from a hot body give out electromagnetic waves. Now these waves are very similar to that of X-rays, and they travel at the speed of light, which is approximately 3 into 10 raised to 8 meters per second. Now these waves carry energy and transfer them to a relatively slow energy or cold body, and thus cause a rise in temperature of a body. So that means that this is a hot body here and this is a cold body here. You would have electromagnetic waves traveling, and these waves carry energy and will transfer the heat energy to the cold body, right? Thus the molecular kinetic energy of the cold body would increase and its temperature would also increase, and this heat traveling by radiation is called as radiant heat energy. You have heat energy trapped in these electromagnetic waves, and which is going to transfer the heat energy to the cold body. This traveling heat energy is called as radiant heat energy. Fine, take on please. What is radiant heat energy? The rapidly oscillating molecules of hot body produce electromagnetic waves. Right? These waves carry energy and transfer them. These waves carry energy and transfer them to the relatively slow energy of a cold body. Transfer them to a relatively slow energy of cold body. Thus, the molecular kinetic energy of the cold body increases. And its temperature also increases. This heat energy which is traveling is called as radiant heat energy. Now, if radiant heat energy, guys, now listen to this. If radiant heat energy is incident on any surface, that means if there is a hot body here, which is giving out electromagnetic waves in the form of radiant heat energy, it is, and these electromagnetic waves are incident on a cold body, right? Now, when radiant energy is incident on the surface of any body, that means this radiant heat energy is going to fall on this cold body also, as a result of which the temperature of this cold body is going to increase. Now, when radiant heat energy is incident on any cold body, then a part of the radiant heat energy incident on it is absorbed, a part of it is reflected, and a part of it is transmitted. You have heat energy which is incident on this. Some part of it will be used to increase the kinetic energy of this. Some part of it is going to be reflected back, and some part of it is going to be transmitted to another body. Right? Three things happen to the radiant heat energy. When radiant heat energy is incident on a cold body, some part of that energy is going to be absorbed, some part of it is going to be reflected, and some part of it is going to be transmitted. And the ability of a body to absorb, reflect, and transmit radiant heat energy depends upon the surface of the body, and it is expressed in terms of coefficient. How much heat energy it is going to absorb, how much is it going to transmit, and how much is it going to reflect. That depends upon how is the surface of the body, and this ability is expressed in the form of coefficient. Then, and these coefficients are called as coefficient of absorption, coefficient of reflection, and coefficient of transmission. Right? Write this down, guys. Right, radiant heat energy what happens to the radiant heat energy? Radiant heat energy incident on the surface of any body that as if radiant heat energy, so radiant heat energy, just make that as if radiant heat energy is incident on surface of any body, then a part of it is absorbed, then a part of it is absorbed, a part is reflected, and a part is transmitted. The ability of a body to absorb, reflect, and transmit radiant heat energy depends upon the nature of the surface. Radiant heat energy depends on the nature of the surface. And is expressed in terms of coefficient. Right? Called three things are happening to it, so you will have three coefficients. One will be called as coefficient of absorption, coefficient of reflection, and coefficient of transmission. And coefficient of transmission. Right, guys, let us assume, let I be the total quantity of radiant heat energy incident on a body. Let I total radiant heat energy incident on a body. If I is the total heat energy incident on a body, let us assume that let IA, IR and IT be the amount of heat energy absorbed, reflected and transmitted. Be the amount of heat energy absorbed, reflected and transmitted. Then from our explanation it is very clear that the total heat energy which is incident on the body undergoes three processes, a part of which is absorbed, a part of which is reflected and a part of which is transmitted. Therefore I can say I is equal to IA plus IR plus IT. Fine. So thus the radiant heat energy, the equation for radiant heat energy I is equal to IA plus IR plus IT. Fine, do we get this thing clear? Now in this explanation I also told you that there are certain coefficients. The ability of the body to absorb, reflect and transmit heat energy is given in the form of number, and that number is called as a coefficient. Let us see what are these coefficients and how do I define them. Right, coefficient of absorption. How do I define coefficient of absorption? It is defined, first of all, it is represented as small letter a. So, right, it is defined as quantity of heat energy absorbed it is defined as just make this, it is defined as the ratio of quantity of heat energy absorbed to the total quantity of radiant heat energy. It is defined as the ratio of the quantity of heat energy absorbed to the total quantity of heat energy incident on it. So in terms of formula, I can say A is equal to IA upon I. It is defined as the ratio of the amount of heat energy absorbed to the total amount of heat energy incident on it, radiant heat energy incident on it. Similarly, I can say that define coefficient of reflection. R. Now, same way, coefficient of reflection is defined as the ratio of the quantity of radiant heat energy reflected to the total quantity of radiant heat energy incident. Thus, I can say R is equal to IR upon I. Right? Then, what do we understand by coefficient of transmission? Represented as T. It is defined as the ratio of total quantity of radiant heat energy transmitted to the total radiant heat energy incident. Thus, I can say T is equal to IT upon I. Guys, but we have just said that I is equal to IA plus IR plus IT. We had derived this when we understood what is radiant heat energy. Radiant heat energy, guys, I is equal to the total incident heat energy is equal to absorbed, reflected and transmitted. We've already done this. Now, if I divide this equation by I, divide by I, So I'll get I upon I is equal to IA upon I plus IR upon I plus IT upon I, which is 1 is equal to A plus R plus T. We just defined these coefficients, so you should have no problem. Thus I can say that A plus R plus T is equal to 1. Fine. So coefficient of absorption plus coefficient of reflection plus coefficient of transmission is equal to 1. Fine, do we get this thing here? Which suggests that if a body has a large value of A, that means if it has a large value of, if large amount of incident radiant energy is absorbed by it, then it is going to be a poor reflector and transmitter and so on. If any one of the values is large, then the other two values will be smaller. Fine, do we get this thing here? Next, what do we understand by figure? What do we understand by a ditherminous substance? Yeah, please space for that now. Derive A plus R plus T is equal to 1. Right, what do we understand by ditherminous substance? Substances through which radiant heat energy can pass are called as ditherminous substance. So if you have radiant heat energy incident on a substance and if it can pass through it, then those substances are called as ditherminous substance. For example, glass, most of the gases, hydrogen, oxygen, all the gases, heat energy can pass through them and therefore they are called as ditherminous substances. Write this down please. Substances through which heat radiations can pass are called as ditherminous substances. Exact opposite of that, atherminous substances. Substances through which heat radiations cannot pass are called as atherminous substances. For example, wood. For example, right, in which atherminous substances are those substances for the value in which the value of T is 0. That means they do not have ability to transmit heat energy. Their ability to transmit heat energy is 0. Right? So atherminous substances are substances through which radiant heat energy cannot pass. Cannot pass. Now, what do we understand by a perfectly black body? Now, black surfaces are found to have fairly large quantity of radiant heat energy absorbed by them. They are good absorbers of radiant heat energy and they have very high value of A. Right? Now, for example, most of the black substances have almost, more than 90% as their value of A. Now, what is a perfectly black body? A perfectly black body is that body which can absorb all the radiant heat energy which is incident on it. Most of the black bodies have very high value of A. Right? If I were to consider lamp black has almost 98% as their value of A. But what would be a perfectly black body? A perfectly black body would be one which would absorb all the radiant heat energy which is incident on it. Right? for which the value of transmission and reflection would be 0, I will be equal to IA. Here, I would be equal to IA. Fine, do we get this thing clear? That's what is a perfectly black body. Right, a perfectly black body, a body which absorbs all the radiant heat incident upon it, all the radiant heat incident upon it is called as a perfectly black body. Right, for a perfectly black body, A is equal to 1. Coefficient of absorption will be equal to 1 and R is equal to 0 and T is equal to 0. So coefficient of reflection and transmission would be equal to 0. Practically, a perfectly black body does not exist. It's only a theoretical concept. Practically, a perfectly black body does not exist. Fine. So, hence for all practical purposes, when you're doing an experiment, you would consider lamp black to be a perfectly black body. For lamp black, the value of A is 0.98. So it's approximately 98%. Right? Now, how do I make a perfectly black body? Guys, to make a perfectly black body, guys, let's see how do I make a perfectly black body. Let's see the construction of a perfectly black body. I want to make a body for which the value of A is 1. So what we do is, guys, just see this. I'll show you the construction of a perfectly black body. Right? What we do is, this particular arrangement that I'm going to show you, it was devised by a scientist called as Ferri, and this is therefore called as Ferri's black body. Okay. Now, the arrangement consists of a double-walled hollow sphere having a narrow opening. This is your double-walled sphere. You have a narrow opening through which the inner surface is of this double-walled sphere is coated with lamp black. So you have lamp black coated on the entire inner surface, and the space between the walls is evacuated to minimize the loss of heat due to convection. This space is evacuated to minimize loss of heat due to convection. Right? Now, you have a conical projection which is exactly opposite to the point of entry. So you have a conical projection which is diametrically opposite to the hole. Right? Now let us see what happens to light when it enters through this hole. I'm going to show you light with a different color. Let's assume I show you light with, say, red color. Now as light energy gets incident on it, light energy, this is light energy moving in. Now because of that conical projection, it will hit the conical projection, and since it is going to hit at an angle, it is going to get reflected. So some part of the light after hitting here is going to get reflected over here. First of all, this inner surface is made up of lamp black. So when the light energy hits the conical part, 98% of the light energy is going to be absorbed. The remaining 2% is going to be reflected. It is going to be reflected within the sphere. Right? It is going to go and hit another black surface. So of that 2% that remains, another 98% will get absorbed. Again, since this is this is a spherical part, you will not have straight reflection, you will have the reflection at an angle. The light energy will again get reflected and again it will go and hit another surface inside the sphere. So another large part of heat, light energy will get absorbed, and that way, due to multiple reflections within this sphere, the amount of light energy that gets transmitted and reflected with every reflection will go on decreasing, and after a point of time there will be no light energy that will be reflected, and thus the total light energy would be absorbed by this, and that's the reason why this is called as a perfectly black body. So by making multiple reflections on the lamp black, I can make sure that the entire heat energy gets absorbed by the body. Fine, do we get this thing here? This construction is called as Ferri's black body. Fine, do we get this? Can we write this down, please? Explain Ferri's black body. Explain Ferri's black body. Right, it consists of, I've just shown you the diagram. It consists of a double-walled hollow sphere having a narrow opening. The inner surface of the double-walled sphere is coated with lamp black. Inner surface of the double-walled sphere is coated with lamp black. I hope everybody knows what is lamp black, what is used in your shoe polish. And the outer surface is polished. The space between the walls is evacuated to minimize space between walls is evacuated to minimize loss of heat due to convection. A conical projection is made diametrically opposite to the hole. A conical projection is made diametrically opposite to the hole. Right? Now, when radiant heat energy enters the sphere, it undergoes multiple reflections. Heat energy enters the hole, it undergoes multiple reflections. During each such reflection, 98% of the heat energy is absorbed. During each such reflection, 98% of heat energy is absorbed. Fine. Thus, within few reflections, the entire radiant heat energy gets absorbed. Thus, within few reflections, the entire radiant heat energy is absorbed. Right? So that's how you make a perfectly black body. Right? Okay, we'll stop this here for the day. Thank you very much.